Hello everyone, my name is Amani Al-Ajmi. Today I'll share my approach to modeling a parametric system inspired by the Google Bay View campus, designed by Big and Heatherwick Studio. The building is located in Mountain View, California and was completed in 2022. It spans over 1.1 million square feet and features a modular triangular roof canopy. In my module, I focus on 5 key elements, which is the roof form, interpanel glazing, the perimeter glass facade, structure frame, and surface pattern, each developed parametrically and derived from the main roof geometry. I started up with a rectangle, which is then divided into triangles and simulated using Kangaroo. Panels were grouped by load and mirrored to form the full roof. Then details were added, such as glass, structure, and pattern. I used the same definition to generate all 3 buildings by adjusting the sliders to control their size and proportions. Here is a look at the final models showing how the components come together. As I explored 2 attempts for generating the main element of the building, which is the roof form. In my first attempt, I used simpler surface generated from a rectangle and then subdivided using diamond pattern. After that, I applied grasshopper to it to manipulate the Z values of the mesh vertices, which allows me to control the curvature of the surface using grasshopper. For the central openings, I used catenary curve to manipulate the realistic structural span, although it didn't respond well to the structural forces, especially on the edges. As for my second and final attempt, I started up by a rectangular base using rectangle component, and then I took the endpoint and connected through a polyline to form a triangular shape. I've also divided the edge point and connect them diagonally to form the triangle, which was then rotated to fill the entire base shape, generating a clean, simple mesh made of 4 triangular sections. We took the mesh after rotating the triangle and used it for the kangaroo simulation to generate the roof curvature. We can also adjust the load and the edge length to explore different tensions, effect, and the roof behaviors, which I'll show you now. So after generating the overall roof curvature, we divided our mesh into 4 segments. Each segment represents different parts of the roof and respond to different load forces. You can see how some of the segments behave differently, especially in the middle part than the edges. And then we ran all the segments into Kangaroo solvers, applying forces settings based on their position. This is the result after simulation. The surface deformed as a whole, while each segment still responds to its locally specific forces. After finalizing the roof, I extracted the mesh faces and I used their vertices to form the glass geometry. And then vertical and horizontal contour lines were added across the glass surface to form the mullions. These contour lines help us to define the glass segment, which were then offsetted and extruded to add a thickness for the mullions. And also we can create parametric changes through playing around with those sliders. For the in-between glazing, I used the same method that I used for the main glass facade, but the only difference is that for the in-between glazing, I extracted the edge between the roof panels, and then I found their midpoint to create a connecting curves, which were then lofted. So after that, I generated the vertical and horizontal contour lines across the glass surface to form the mullions. So as for the structure system, I created 2 types, one for rectangular roof panels and the other one for triangular ones. Starting up with the rectangular roof structure, I took the B up and then I applied to it a triangular panel C, and then we added a thickness to it using pipe. Because we don't want the structure to be connected with the panels, we moved it downward in the negative directions. As for the triangular part, we took the mesh and then we scale it down. The idea is that we want to return it back to its original state, which is 4 corners. After that, we added triangular panel C and then projecting it back to its place. And then we also moved it downward because we don't want the structure to be connected with the panels. So here is the final result of the structure. For the roof pattern, I developed 2 systems. one of them for rectangular panels and the other one for triangular panels. On a rectangular surface, I applied a diamond grid using diamond component, which was then rotated and moved in the negative direction to form the pattern. Here you can see the pattern after the rotation. For the triangular panels, I used unified face edges to generate the triangular curves. Then it was projected and joined them using patch surface. After that, we applied a diamond grid using the diamond component. Here you can see the pattern after the rotations. As for the columns, I'm extracting the mesh edges to create the curves. After that, I'm using the bounding box to scale them down and to center them. I've also duplicated and adjusted these curves to form a lofted vertical column that connects smoothly with the roof and follow its geometry. We can also play around with those columns. And here are the final results.